Hello and welcome back to Elementary Algebra, section 6.6 on solving equations by factoring. So we skipped a couple of sections in chapter 6. Those are all part of intermediate algebra. So the only sections we cover are 6.1, 6.2, 6.4, and 6.6. So those four sections. And the rest are in intermediate. Now, we know what solving equations means, right? We know that that means calculate x when you have the equation that has the equal sign, so you can solve it and compute the value of x. So we go back to that story of expression versus equation. So expression is like 3x plus 6. That's it. 3x plus 6 is expression. 3x plus 6 equals to, I don't know, 18 is equation. So the clear difference is this extra stuff with the equal sign. So now for expressions, the only things you can do is simplify. We can simplify. And that's it. There is literally nothing else. This F looks weird, but whatever. So there's nothing else we can do. So in our case, you can just say, okay, 3x plus 2, and you're done. That's the most you can do. Now, for equations, we can simplify, but we can also solve for, in this case, for x. So we can, we can factor 3 and then divide by 3 both sides and all that, or we can just subtract 6 to get 3x equals to 12, divide both sides by 3, and get x equals 4. So these two worlds are completely different, right? One is just the world of simplify, and the other one is world of solving. And in order to solve, right, you have to have this. You have to have equation, you have to have equal sign, and you have to follow the rules. Now, the equations in chapter 6 are going to be quadratic equations, which you would be solving by factoring of some kind. Whether it's going to be GCF factoring or grouping or, whatever we learned. So one of those factoring methods will apply to the problem, and then you will be able to solve that problem. So let's take a look at two problems side by side to see the difference in what we pick as a factoring technique and how close these are, and everything we can do. So we start with x squared minus 4x equals 0. And over here I'm going to have x squared minus 4 equals 0. So these two problems are very close, right? The only difference is this x. Other than that, everything else is the same. Now, when you look at these problems, they will actually use different methods of factoring. The left one, does anyone see what factoring I should use on the left problem? I mean, if you know what is the one on the right, you can say that as well. Remember, we are factoring. Can anyone tell me what are the 4 different types of factoring that we talked about in this course? In other words, did anyone study anything from chapter 6 yet? What are the 4 factoring techniques that we learned in chapter 6? What's the first one? Are you guys still there? Awake? It's not a trick question.
I grabbed my note.
All right, I guess I'll have to GCF grouping,
Oh.
then x squared plus bx plus c with those numbers that we guess, and then 4 is special. So those are our 4 ways to factor a problem. The first one, right, the left one, is obviously GCF because we can kick x from both of these terms and have x minus 4. So now we are ready to solve the problem all the way down. Now what we are going to use is something that is called zero product rule. And I will write that rule below. And the zero product rule tells you to take each of the factors and set them independently to 0. So x equals 0 and x minus 4 equals 0. Now this one you can solve by adding 4, and there are your answers. So we have 2 answers for problems that have square. So what you call quadratic, right? Problems, so equations, they would have 2 solutions. So we have x equals 0 and x equals to 4. If you take a look at the other side, it's the cheapest possible. Which one? Can you repeat that? I didn't catch it. Maybe it was a glitch in the matrix. So this problem here is special factoring. So it's just x minus 2, x plus 2. That was from the last class, when you have a difference of squares. So square root of x squared is just x, and the square root of 4 is 2. So we have x minus 2 equals 0, and x plus 2 equals 0. We solve each one of these independently. We get x is 2, and on the other side, x is negative 2. So we have, again, 2 solutions. And you can see that just adding this one x here changed the way we factor, and obviously change the solutions as well. So we just have to be very careful. We need to know all 4 methods of factoring. When you go into intermediate algebra, you'll add another one, and then right, you'll have 5 options. Now in elementary, you have 4 options, which is fine. And that's the way we go through all of these problems. So to solve quadratic equation, we go simplify to factor using any method. So factor using any method. 3. So simplify, factor 3, zero product rule. And I'll explain that one. And now 4, solve each linear equation. Step 5, win. Simplify is not always used. Sometimes you can bring, you can do like terms, and add and subtract like terms and so on. Or maybe divide the entire equation by 2 or something to reduce numbers. So sometimes that's possible. And then you get to the very important step, which is factor. And that's anything goes. So whatever method you know, whatever method fits, you use that to factor your quadratic equation. And then once you factor everything, you are supposed to use the zero product rule, because that is the rule that breaks the factors into separate linear equations. And this is what I want to now write here on what is the zero product rule. So if A times B equals 0, then A equals 0 or B equals 0. That's all it is. So if I have x plus 3 times, let's say, x minus 1 equal to 0, by zero product rule, I can set each one of these to 0. Because if you compare this, your A is the first parenthesis, your B is the second parenthesis, and you just wrote these ones out on the bottom. So that's how we actually solve these things. We factor, and then we take each factor and we set it equal to 0, because the zero product rule says that that's exactly what we are supposed to do. Now, that rule is not arbitrary. This rule makes perfect sense, right? If you just consider A times B equal to 0, you can have A to be 13 and B to be 0, and you have a 0. You can have your A to be 0 and B to be 7, and you still have 0. So, one of the two numbers of A and B, or expressions or whatever, so one of them has to be 0 in order for product to be 0. They could both be 0, and the product would be 0. So it's not arbitrary rule that someone came up with, so you have another thing to memorize. It is actually a very important rule, because we solve a lot. I mean, this propagates through calculus and differential equations, like calculus 4. I had to use this actually last class. So this method never goes away as you are taking higher courses in math. So you really need to know the zero product rule, which allows you to break this one equation, which had a lot of stuff in it, right? To break that one equation into 2 or more very easy equations to solve. So that's also something worth mentioning, that we can have more than just A and B. We can have as many of these parentheses and constants as we want. So if for some reason you need 20, well, it can be done, right? Just A times B times C times D times E, right? You go all the, first 20 letters of alphabet in terms of, right? But as long as one of them is 0, everything goes to 0. So you can literally have any one of those. I'm going to write that here as a rule. So we can have more than 2 factors. So A times B times C times D is equal to 0. And then over here you say it's A equals 0 or B equals 0 or C equals 0 or D equals 0. So all of those, but for the purposes of the problem, all I need to do is to set each factor, each parenthesis that I get, set that one to 0. So let's see more examples. So let's say you have well, actually, I don't have to make them up. I can just steal them from homework. Oh, let's practice this. So let's say you landed on y minus 1, y minus 2 equals 0 in the zero product rule. Well, you're not going to FOIL this because then that's just going to go back in the original problem and your factoring and right was for nothing. So what we do is we use zero product rule where we separate these into two of these, and then we have y is 1, add 2, y is 2, and that's it. So zero product rule is when you go from this step to this step, where you break apart these factors and each factor gets its own equation. Now, let's say problem 24 says x plus 1, x minus 6 equal to 0. Well, if you have this, all you need to do is to set each factor to 0, and you have 3 of them. So x is 0, x plus 1 is 0, and x minus 6 is 0. The first one is already solved. There's nothing to do there. The second one, you subtract 1. You get x equals minus 1. So that's another solution. And over here you add 6 to get your x equals 6 solution. And you have 1, 2, 3 factors, 1, 2, 3 solutions. They always have to match. So technically, this is the only skill you are learning now, because factoring, which you have to do in every problem, was not taught in this section. It was taught in previous sections. But this zero product rule is the new thing that it's in this section. So anytime you have a mathematical equation, your job is to factor it. Once you have factors, you set each factor to 0 and solve those cheap equations. They are literally the first day equations, right? I mean, subtract 1 on both sides. Come on, right? So now we can jump into, again, some of the homework exercises and examples. So I'm going to ask you to tell me what is, oh, I forgot to put a 0 there, sorry. So what is the GCF for this problem?
3z.
3z is perfect. So when I kick 3z out, what are the leftovers?
Z minus 2.
Well, 3 into 6 goes 2 times, and then 1z. So 2z is the first. What's the second one? Over here.
Was it minus 1?
Yes, very good. When you factor out everything, 1 stays behind. Now, whether it's a plus and minus, that depends, right, with the sign of the problem. Awesome. So now, zero product rule. And now we solve these individual equations. Now, divide both sides by 3. you immediately get z still 0. So that's one of the good solutions. And on the other side, you add 1 first to get 2z equals 1. And then you divide by 2 both sides to get your z is a half. So this is what we have for the entire section. Factor, 0 product rule. They call it in the book 0 product property. Whatever. Rule property. You can use whatever language you want there, as long as you do this correctly. Any questions, concerns on this one?
So everything we learned up until now boils down to like this process.
Everything we learned is actually right in this section. This section puts chapters 5 and chapter 6 in same. I haven't showed yet chapter 5 portion of this, but that's the check procedure, right? For those students who care, you can check your answer, because you will say 6 times 0 squared minus 3 times 0 equals 0, right? You're asking yourself, well, that's 0 minus 0, which is equal to 0, so 0 is a good solution, right? It's really nice when you have equations around, because equations can be checked. Now we can go and check the other one, which is 6 times 1/2 squared minus 3 times 1/2. And is that equal to 0? And we do the same thing. This is going to be 6 times 1/4 minus 3/2. Is that equal to 0? Where when you cancel 6 and 4, you get 3/2 minus 3/2, and that's a 0. So yes, both of these are perfect solutions, because when you plug them back in original equation, you get the true mathematical statement, in our case 0 equals 0 across the board. So this is why I absolutely love equations. I can check them and I know it's correct, because right, I plugged the value in and it worked out, and that's it. That's the end of the story. Now let's take a look at a couple of these problems. Oh, by the way, it's over, right? That's it. There's nothing else other than factor, zero product rule, solve each one of those small equations, and you got your answers. That's what this section is all about. Now we can make it a little bit more interesting, right, with some more complicated factoring problems, like problem 36, for instance. I don't like using z's too much, because some of you do not cross them like this, and then they look like 2's, and then you start confusing them midway the problem and all of that stuff. So I'm trying to kind of keep away from z. I can't, obviously, because of calculus 3. I have to, I have to love and respect z as a variable. But when I see it here, I can avoid it, I guess. So I'm rewriting problem 36 from z's to x's. So this is a quadratic equation, and no GCF. Grouping needs 4 terms. This has 3. It's not special either, because square root of 3 is not the whole number. So we are stuck with that a plus, x squared plus bx plus c factoring when you're looking for those two numbers through the list of values. Now this one is easy, because it's just 3, which are just 1 and 2. And if you want, I said this one is easy. It's not easy, right? It's not easy. So we need a negative 3, which means one needs to be negative, one needs to be positive. And yeah, that doesn't happen. Because if negative 1 plus 2, negative 1 plus 2 would give us a 1. And if we put a negative here, it will be 1 minus 2, which is negative 1. Neither of the two will give us a 2 we need. Oh! What the hell? I can't divide 3 by 1 and get 3. The factors are 1 and 3. Well, this was terrible. And no one called me on it either. I have no clue if you're paying attention right now. How didn't you catch that I put 1 and 2 instead of 1 and 3? This is the last class where you guess the two numbers. And as you can see, 1 minus 3, that's a negative 2. So we can just write this as x plus 1, x minus 3, and now zero product rule. Subtract 1, x is negative 1, add 3, x is 3. So that was that harder factoring. And some problems, remember how I said the step there is simplify first and we never used it because all of the problems that we got were already simplified? Some problems which are designed for just math exams and homework annoyance will have to implement that step. So let's say you have y minus 7 equals negative 12. This doesn't look nice in order, the way we're used to it. And the other thing is that you can't separate these now because this is not 0, it's negative 12. Our rule is called zero product rule, not negative 12 product rule. So I actually have to multiply this and do all of those calculations and move 12 to the other side to get 0, and then see where I can go from there. So when I distribute y, I get y squared minus 7y. And now I add 12 to both sides. Now when you add 12 on the left, it doesn't add to anything. The right-hand side gets 0 because 12 minus 12 is 0. So now, this was all step number 1 to rewrite the function and simplify the function, the equation, not the function. Equation to come up with the equation that we can work with. Now, we just do factors of 12, which are 1 and 12, 2 and 6, 3 and 4, and we see if any of them can add to negative 7, which is negative 3 and negative 4. So y minus 3, y minus 4 equals to 0, 0. And now, this is where we use zero product rule to kick each one of these out. Add 3, y is 3, add 4, y is 4. And those are our answers. It's a very systematic problem. You ask yourself, do I need to simplify it? If not, then we go to factoring and I use whatever method. And the answers pop out. That's all it is. All right, so I'm going to put one of these for you to enjoy. Yeah, the 47 looks good. And weird. 3m squared is equal to negative 9m. All right. You got 22 seconds, no pressure. Go. What would be the first step? Would anyone like to share the first step for this problem?
Would it be GCF?
Well, we have to do something before. So we will do GCF. That's perfect. But we have to do something before we go with the GCF.
Do we have to simplify to get 0?
Yes, we have to simplify to get 0, which means what do I have to move?
Minus 9m?
Excellent. So we'll add 9m to both sides to remove the negative 9m. Now, on the left-hand side, they do not add together because they're not like terms. And we got that 0 on the right. So you always have to have equal to 0. Then you are allowed to factor. If you factor before that, then, I mean, you can't factor over, right, equal sign over there and stuff. So you do have to have these things separated. Things that were separated, you have to have them on the same side. And now you can factor. So you said GCF. Now, what would be the
plus?
What happened?
Wouldn't it be plus the 9?
Oh, yes. Thank you. Yes, you're right. It will be plus 9 because we are adding 9 to both sides. Very good. This is where I can pull a good old instructors. Oh, I knew that all along. I was just testing you all. Anyway, what is our GCF in this case?
3m.
3m, exactly. So we kick 3m out, and what's left?
Is it m minus 9? No, wait a minute.
It will be Well, now the sign is plus because
plus.
I fixed the mistake. So it's going to be m plus, and how much is 9m divided by 3m? M's are clearly cancelled. 9 divided by 3 is?
3.
3.
So 3m.
All right. So we got this factored. And now that it's factored, I'm going to use zero product rule to separate these into 3m equals 0 and m plus 3 equal to 0. So on the left hand side, we are going to divide by 3, which still gives us m is 0. And on the other side, we subtract 3 for m equals negative 3. And there they are. So I hope this makes sense. If it doesn't, please ask right now because we need to fix it. Here you can see the whole problem. No questions? All right, let's do another one. This is problem 49. Again, textbook. X squared equals 5x plus 6. Let's see what you get. Would anyone share what the first step is, at least?
Well, we need 0.
Make a 0 on the right-hand side. Good. So we have to move 5x and a 6. Okay, that's perfect. So hopefully everyone is doing that now. All right, so we subtract 5x and we subtract 6. Now nothing adds together because they're not like terms. And now we can, I hope, right, we can factor. So any ideas on what those factors should be?
Is it 1 and -6?
1 and -6. Okay. So 1 and -6, they multiply into -6, they add to -5. Perfect. So x plus 1, x minus 6, and everything equal to 0. All right, what next?
You do x plus 1 equals 0 and x
Yes.
minus 6 equals 0?
Yes. It's called the zero product rule. So we set each one of these parentheses independently, right, to their own 0, right? And then we solve simple equations here. So x is -1 and x is 6 when you add 6 to both sides. And that's it, guys. I mean, if you are able to factor, you are able to do this section. If you're not able to factor, well, then you're not able to do anything in chapter 6 anyway. So, right, whatever. But the deal is that right, you simplify if you can, and then you factor, then use zero product rule, and then solving those resulting equations is always a joke because they're always very simple, 1 or 2 calculations at most, right, 2 steps. But in our case, it is only it is only this one where you have the right 2 of these values. Now, what we have, I hope you picked this up. I know I said it at the beginning of the lesson, but we have 2 solutions. And that's because the problem was squared to begin with. So make sure that when you have single x problems, you have one solution, and when you have these double, x squared, which are called quadratic, then you have when you have 2 solutions as your answer. And that takes care of the section. So
I have a question.
Yes.
We got x equals -1 and x equals -6, right? Or sorry,
Positive
6.
Uh-huh.
Yeah. So how would you like check this? Is there a checking method? Do you just
Yeah, you plug them in the original problem. So we'll check
and then you
both
get the
answers.
answer, right?
So we're checking x equals -1. That's -1 squared should be the same as 5 times -1 plus 6. -1 squared is 1, and on the other side I have -5 plus 6. 1 equals 1. That one checks out. Now we check x equals 6. That's 6 squared should be equal, and that's why I put this equals this question mark on top of the equal sign. Should be equal to 5 times 6 plus 6. 6 squared is 36. On the other side, 5 times 6 is 30 plus 6. 36 equals 36. The second problem is good.
Perfect.
So
Thank you.
in that sense, yes, you're welcome. So that's the way we check every single one of these problems. Always the same way. Okay. Any other questions, concerns, anything?
No, very productive class.
Yeah, this was clean. Well, if no questions, then guys, I will remind you the office hours, right? Every day. The schedule is except Fridays. Schedule for office hours is in Canvas. If you run into any additional problems and issues, stop by office hours. I will open the homework now so that you can enjoy those exercises, and see you Thursday. We're going to review all of this on Thursday, and then do the next section, right, as we are closing into the final 4 weeks left, with 1 week of break in between, I guess, whatever you want to call it. So yeah, I will see you later. Bye.
See ya. Thank